name is Miguel Ángel Manso. In the second lesson, part 2 of the module Representation and New Technologies, we continue learning in a practical way about data presentation as time series applied to networked control system context. Working with RStudio free version, we can download it from http://www.rstudio.com/product/rstudio/download/ and install it. Install libraries T-Series and Forecast. To do it, we can navigate through Tool menu and select Install Package option. Before, select Repository and write library name, T-Series and later Forecast. We can proceed to install. Define working directory. In order to select the working directory, we use setwd command and provide the pipe directory between the parentheses. Libraries, load libraries to use. In order to can use libraries with the current workspace in RStudio, we use the library command, indicated in parentheses the name of the libraries to be used, separated by a comma, T-Series, Forecast. Load table data from text file. In order to read data from table stored in a file, we use the command read.table, indicating the data frame variable in which store data, df: and the file name in the parentheses :.dat. Convert and store in T-Series variable column number 2 of the if $b2 to time series starting on 8 September 1942 with daily data. Plot time series defining axis label. To plot time series, we use the command plot indicating as parameters the time series to plot T is column, representation type B to plot and lines, and axis label X and Y. Visualizing time series data. Practical exercise. With cumulative rainfall in Santiago de Compostela, we can do same as before. Read table data from file and store in a data frames variable df is the rain. The problem in this case is that the table data are transposed. In order to correct that, we can get is a matrix data from data frame, data.matrix, then transpose t, and finally save as vector in a new data frame variable rain. Next, convert data frame to time series variable t is the rain, starting in January of 1988 and monthly frequency. And finally, plotting the time series t is the rain with the plot command. Decomposing the time series data. Practical exercise. RStats library provides the compose function. The seasonal component can be traced at additive or multiplicative. By default, additive decomposition is used. To do it, we store in the compose attribute of this is the rain variable the result of the command decompose using as parameter this is the rain time series. Then plot the result with the plot command. Decomposition of the CO2 series monthly data. In this case, the CO2 variables available in the TSA library are displayed after the decomposition additive the series. The decomposition of the series another time aims to isolate the trend, seasonal, and innovation or noise or rest. Decomposition time series, a practical exercise. In this case, the data is stored in TSA library. To use them, use the data command and indicate the name of the variable and the package as parameters. Later, we can decompose CO2 series and save the result in the comp attribute of the same variable CO2. Finally, plot the composed result with the plot command. Visualizing and decomposing mean temperature in Madrid. With the mean month temperature in Madrid in the last 30 years, we can do same as before. Read table data from file and store in a data frame variable dft Madrid. Next, convert data frame to time series variable TSTM-MAT starting in January 1988 and monthly frequency. Then plotting the time series to TSTM-MAT with the plot command. And finally, plot the composition of TST-MAT series. The file with the data can be obtained from the link shown in the slide. That's all. Thank you. See you soon.